One way to solve a system of linear equations is by solving one equation for one variable, and then substituting the expression for that variable into the other equation. This method is known as the substitution method. When a system of equations has at least one equation that can be easily solved for a variable, the system can be efficiently solved using substitution. Let's consider the following examples. In this case, since the first equation is already solved for y, we substitute x plus 2 for y in the second equation. 2x plus 3, x plus 2, equals 16. Distributing and simplifying, we get 5x equals 10. And solving for x, we find x equals 2. Substituting x equals 2 back into the first equation, we find y equals 4. Therefore, the solution to the system of equations is 2, 4. Let's consider the second example. Here, we rearrange the first equation to express y in terms of x. Then substitute this expression into the second equation. 3x minus 2, 2x plus 3, equals 5. Distributing and simplifying, we find x equals negative 11. Substituting this into the first equation, we find y equals negative 19. Thus, the solution to the system is negative 11, negative 19. Let's consider the third example. In this case, neither equation is conveniently solved for a variable. We choose one equation and manipulate it to solve for one variable. For example, let's choose the first equation and solve for y, substituting this into the second equation. Multiplying both sides of the equation by 3 eliminates the fraction, making the calculation easier. Simplifying this equation, we find x equals negative 1. Substituting this into the first equation, we find y equals 2. Therefore, the solution to the system of equations is negative 1, 2. See you next time.